Good evening all, this is Vijay Kirti. So welcome to this webinar for application of artificial intelligence and big data in IoT space. Basically, I am working as a data scientist. I have 7 years of work experience and I have worked across multiple problem statements, and IoT is one of my favorite areas. The agenda for this webinar is going to be highly simple. So what I'm going to do is I will introduce you to IoT, and then there's going to be a big data introduction, artificial intelligence introduction, and there are two case studies which would I want you guys to have a look at it, and then we will end up with a career path in IoT space and machine learning, followed by questions and discussions. So this is going to be the agenda, and let's get this started. So what is IoT? So IoT is basically connected devices with a lot of interactions happening among themselves, and there is no hard fast rule that this is going to be your IoT and this is not. So it's about X number of devices getting connected with each other, talking to each other, and doing a lot of communications. And this IoT, Internet of Things, how it is being used across big data, artificial intelligence is something fascinating. And what we will be doing is have a look at what is the trend of IoT, and then we will quickly move on to big data and artificial intelligence. So let's have a look at this particular infographic which I would like to show. So this is something which we are talking on, the growth of Internet of Things, and we have taken the trends for the past 2 decades. And the thing is, by 2020, it is estimated to be 50 billion devices, and currently we are close to 29 billion, which means we are going to see a 50% increase in the number of devices which are getting connected to each other and having a lot of interactions. And on top of that, what is fascinating is machine learning, artificial intelligence, and the tools required to pull insights and have recommendations on top of it. Now, when it comes to big data and Internet of Things, it's more about understanding the basics of big data, which is volume, velocity, variety, and how good the data is, how fast the data is. Is it a click stream, or is it a continuously streaming data? When I talk about artificial intelligence, it's more of a huge, application oriented space. Let's say, self-driving cars, traffic recognition, onboard diagnostics, Amazon Echo-based alert system, and things like that. So the key focus areas are going to be, as listed below. It's going to be home automation, self-driving cars, and there are a lot of applications across telecom, automobile. Wearables is one of the most upcoming areas. Let's say, Google Glass or Samsung of the world. And you will also have a lot of applications across oil and gas. When I talk about oil and gas, it's more into safety planning, optimization problems, and how good and how efficient we can carry out things. And the last one, manufacturing, it's more of predictive maintenance and preventive maintenance as well. We are looking into how we can use the existing systems and have a better service mechanisms. So this is something we are going to talk with respect to IoT, but this is not again limited to. Now, the basics of big data. This is something almost everyone would have heard of, but I would say this is the most basic thing which any data science or machine learning, or somebody is interested in IoT must know. So volume, velocity, variety, and veracity. Again, volume, we are talking about petabytes and zettabytes of data. And when I talk about velocity, how fast the streaming data is it per second, or is it per minute, or is it just per day, or even fractions of seconds? So that will again impact your IoT platform. And then the most important thing, what kind of big data tools you're using. When I say streaming data, the tool which you use should be highly performance oriented. And the third one is going to be variety of data. Let's say social media, and I'm talking about video data or image data. So any big data tool which you are using again should support the different varieties of data. And the veracity. Now, veracity is most difficult to handle. It's highly uncertain. We do not know what kind of data it is going to give, what kind of users are going to ask, and what kind of uncertain things are going to happen. The reason is, multiple people are using and multiple geographies are linked to each other. Now, considering all these four criterias, I would say whenever you want to choose a big data tool, this is going to be your basics. One out of these four will definitely impact the business. And the point is, out of my experience and knowledge and whatever I have heard, at least two should get, added to that big data tool, whichever you select. When we are going to address any platform, it's not just about IoT; it's about any platform. And when you are able to see that at least two are getting solved, then that we it means that we are on the right track. So this is about the basics of big data. But anybody who wants to really use this particular platform should be very aware of these particular concepts. Now, artificial intelligence. So I will be spending enough time on this. What I would say is, this is not again limited to. It's more of using multiple things to improvise the insights and use how good you can. Now let's say chatbots. So this pyramid will clearly tell you, how the particular business is being driven, how people are using multiple technology tools to use artificial intelligence in IoT space. Now, I would like to highlight on the first one, chatbot. So we have heard a lot of frameworks on chatbots, lot of applications on chatbots, and how it is being used across multiple scenarios. The point is, chatbots is something which people use to gather information and then give the required answers. When it comes to IoT space, your chatbot is going to slightly work in a different way. You want to understand how much information you will get across devices and what is the information the other device is seeking. It can be in safety areas. It can be in let's say optimization areas. So the chatbot works in a way that the more the data you feed, it understands better and it starts responding in a better manner. Now, when I talk about deep learning and natural language understanding, it's more of high-end processing algorithms where you use let's say CNN, RNN, and LSTM and GRUs of the world, and try to make the algorithm understand that whenever such a pattern is available, it means that you need to do say let's say an X thing or a Y thing. But the point is, what we want to grab out of this particular slide is how much of companies are working, how much of research is being done on all these areas. And again, everything is very specific to Internet of Things. So let's say natural language understanding. A quick example is, nowadays we can see that there are support executives who will answer to your queries. Now, when we find that we are able to train the chatbot and make it understand using NLP algorithms, then there is going to be an automated tool or an automated software which can answer any question and give you better answers. So that's the kind of research, and people have come up with some wonderful tools which can answer any question and then gives the appropriate answer. So that is something NLP does. And what we try to do is, let's say an IoT company wants to use NLP as a support platform. What they try to do is, they use these chatbots, train them with a lot of NLP algorithms, and make the people understand on multiple IoT products. Let's say I want to have a Wi-Fi router which can control my PC, and I just give, let's say, in a chatbot that I want a Wi-Fi router to control the PC. Now what it understands using NLP algorithms is that a person A or B wants to control the laptop or desktop using Wi-Fi as a medium of controlling mechanism. So there is going to be a frequent talk between a laptop or a desktop towards the Wi-Fi, and it's going to happen vice versa. But the point, overall, the understanding should be that you need to train the machine learning algorithm. And the reason artificial intelligence is that you don't need to do it every time. It let's say if the chatbot is not sure of any question, what it does is it tries to say in a very different way that I'm not sure of this. I would like to answer it sometime later. So what it does is, meanwhile, when it gets the actual answer from, let's say, some other person, the next time you come up, you will get the answer. That's the best part of artificial intelligence, and it is highly automated. We don't do we don't repeat multiple tasks. What it does is it tries to understand on its own and gives the answers. So this is about artificial intelligence in IoT space. So what I will be doing in the next let's say 15 or 20 minutes, I would want to cover two case studies: one, big data in IoT, and artificial intelligence in IoT. So this particular big data in IoT case study is a real implementation. It has been done by a lot of companies across the world, Agroland and multiple other companies who try to use big data and IoT as a coupled technology platform to improve the lot of to improve efficiency, increase the number of yields, and also lower cost. It tries to optimize everything. And on a high level, I do not want to get into the low in depth of the technology, but on a high level, I would say the people have used R, Hadoop, and geospatial tools, and the technology is more of using RFIDs and biosensors, gates, and let's say techniques. It's again random forest tree models, but not limited to. Again, it's going to have a very high chance of using neural networks as a algorithm to implement this particular case study. Now, coming to the business problem, there are a lot of livestock, a lot of images. There's going to be huge amount of streaming data, and you can see that the livestock is moving here and there. And the other part is you have a lot of weather factors, biological factors, which again would add to the challenge. Now, the question here is, how do I increase my yield and lower my cost both in parallel? So these people have actually used all these tools and technologies. They have come up with a, say, a huge implementation by using these tools. There is going to be two parts to this: one, a real time algorithm which runs on the live data, and as well you will have a batch processing which does lot of activities behind the screen to understand how to improve yields, and again how do I lower my cost. So the solution is highly technology oriented. It has a lot of scope in image processing again. But overall, what we try to focus here is how are these devices connected with each other, and how are we using multiple sources of data. Let's say I use satellite imagery data, I use RFID tag data, and I also have my biological and weather related factors, which is again stored in some database. And I have to couple all these things because each one has its own frequency. Let's say I talk about satellite imagery. I'm not going to get say every second. It's more of over a long period. Whereas RFID data, I'm going to give it every second. So remember, we were talking about uncertainty of data. This is more on those lines. I don't know, and I'm not sure how frequent am I going to get, and what is the different type of data am I going to get. So these kind of challenges are always posed in any big data tool. And when it comes to IoT, these challenges are something which should be handled and should be trained before a real time challenge occurs. That's why we do a lot of testing of algorithms. We do a lot of even training of algorithms. We try to focus more on the efficiency of the model. So this helps on understanding what kind of technology challenges we have, and also where do we use machine learning algorithms coupled with big data and IoT platforms. So this is more of a implementation, and let's say the company was able to understand all the complications, and they were implementing it. And yes, they were able to lower significant amount of cost, as well as the yields were really huge, more than the cost. They were able to have a lot of output factors which actually was consumed to the end business. So this is more on a practical application oriented case study. This is again not limited to using only these kind of tools and technologies. Probably you can use multiple other tools for the same case study, but this is more on understanding perspective of how are we using the all the tools in the market and bringing out the best of it. This again ties back with your basics of big data. You need to understand how complicated and how well equipped are we to create a platform. So this is on the lines of a big data case study in Internet of Things. Now, the next case study is going to be more of using artificial intelligence in IoT. So these are something which people might have heard of. Let's say in a realistic scenario, when you go to a manufacturing industry, you have a lot of managers, you have a lot of workers, and there is chances of immediate issues coming where an on-field technician should go and look at it. Now these people who did this particular implementation used Amazon Eco, and what they did is breathtaking. They understood the multiple data platforms. They processed it. They used artificial intelligence on top of it, and basically what they did is they tried to simulate a human being handling multiple other situations. Let's say when I understand that a machine A is going to have some problem, using the historical data, the algorithms are able to predict that this machine A is going to face such a problem at this particular time, or let's say in the next 24 hours. And what this device does is it opens up for the technician who is going to work on this particular issue, and warns him that this is the time limit which you can have and you need to solve this, and if you're not solving, these are the complications. Now, coming back to the situation of where the industry is located, right? You have let's say you have 100 technicians. When you actually implement this particular platform, you don't really need 100 technicians, because it also prioritizes the issues and says that these are the set of issues which you need to solve at the first, and these you know to solve in the next upcoming 24 hours or 48 hours. And this is one of the complicated platform, I would say. Again, the tools used are R, or you can also use Python, or you can use any particular machine learning tool. There are big data platforms, and there is also voice recognition. Now I would like to highlight something on voice recognition. This is a very huge area and people explore a lot of things. What we see that we use neural networks, we use LSTMs to make it understand that this is what a particular person A is responding. Let's say the algorithm predicts that an issue A is going to pop up in the next 24 hours. And what the technician does is, in return, he also asks a set of questions. Okay, tell me where is the location available. Tell me how many number of backup machines I have. So when the person asks these kind of questions, what it does is it understands the person voice. It decrypts that this is the text, or this is the transcript he was talking about, and then goes and searches the database whether that such a possibility is available, and takes up the answers required for that, and again comes up with the end solution that the location is let's say 500 meters towards your south of this particular point, and you have other tools like this available in that location for it to solve. So the intelligence level is very high, but there is a lot of complications in training the algorithms. Let's say even if you want to train your neural networks, or if you want to train your LSTMs, what we try to do is increase the amount of training data and make it understand that these are the possible challenges which occur, and these are the questions we ask. The more the questions are asked, the more the algorithm is getting trained. Now, coming back to the actual problem, you can see that I have highlighted two different things: proactive voice-based alerts, which we were talking about, where Amazon Echo, or any device would do that. I think Google also has come up with a latest device which can put down alerts which can do voice recognition and process the data. Then voice recognition based initiating system changes. Now let's say a technician wants to switch off machine B. All he would do is he will understand that based on the alert, I don't want my machine B to run further. So he goes and gives a command, switch off machine B. Now what it does is it understands that person B has asked him to switch it off, and since these guys are highly connected with each other using Internet of Thing platforms, or let's say they are connected in some mode of communication, it goes and switches off. Now, what happens as a result is the machine B is saved from a huge problem, as well as the efficiency is not being disturbed at any cost, and thereby the throughput is also adjusted because as a result, let's say you have 100 machines and one particular machine is being switched it off. Now the remaining 99 has to work in such a way that the demands are kept up, and the complexity is not being brought to the table in the form of a low output. So this is more of highly intelligent platform, and we can see that lot of startups and lot of companies have started using this. I would say that Tesla is one such company who does wonderful things using artificial intelligence, voice recognition, and all these guys are highly connected to each other. So there is no way that we can see just an alert. We also see a solution. We also see what else can be done to compensate that. Now this is the business problem being talked about. Now coming to the solution part, there are three parts to it. One, you have your IoT space where all these guys are connected. Number two, you also need to understand that whenever there is an IoT, a proper big data tool or a platform should be made available. Let's say I use Hadoop, or any particular technology or a tool to capture that data. The third part is your core machine learning engine on top of the data. And what I mean by artificial intelligence is not just building a model, but taking it to the next level, making people understand that there is going to be a precautionary alert, or there is going to be an emergency alert, or this is just a cautional alert. And apart from that, you need to answer the questions being asked by the field technician, because there are a lot of complications on the field which he would like to solve. Let's say I raise an issue. The algorithm says that the probability of a machine failure is just 60%. Now it's up to the technician to either continue or discontinue. So what he says is, no, since it's just 60%, I would say let's go ahead for the next 24 hours. So it means that after 24 hours, whether the person is present or not, these communication devices are used understand the answer given by that particular technician and switch it off just after 24 hours, thereby increasing the efficiency and also understanding what is being asked and what is not being asked. So the differentiation between what is being asked and not asked is more of intelligent algorithms can understand it, and in practically it understands the other complexities and prioritizes. So I think even Uber uses artificial intelligence. One of the best use cases is self-driving cars. This is more of a research area, but we can see that Google and Tesla were able to come up with successful implementations. But still, there are certain challenges available. One of the cases where Google wasn't able to figure out was highly moving, traffic zone. There are multiple people coming in, and the face recognition was absolutely a big problem, because what it can see in the nearby is more prominent. What it can't see farther from the car is prone to error. So this is more of a safety issue, and there is a lot of complications and humans are involved. So hence the better algorithm is being implemented, the better output. When it comes to Tesla, I would say that particular artificial intelligence implementation is slightly different. They are focusing on self driving mechanisms and also safety. They are focusing on engine performance. One such part of engine performance monitoring using IoT is onboard diagnostics. We try to see, how we can improve the diagnostics characters, and of late, people are using it as a service mechanism. Let's say, any luxury car provider wants to understand how his customers are currently. Are they running towards problem, or they are going good? What I do is I try to understand their data. I just say that, being on the past historical data, I feel that it's time for you to come for a service, or it's time for you to change such a part, or just come for a general checkup and things like that. Because that's the service impact towards the brand value. Let's say, BMW or Benz or Volvo come with such a feature. It's more of giving the customer the highly sophisticated service mechanisms, without the customer being prompting and say, I'm facing some issues. So it is more of a proactive approach. Now artificial intelligence is being used in such a way that it's not just about using neural networks or LSTMs. It's more of understanding customers wants, customers needs, and then coming up with solution which actually is in demand. So let's say, I do an artificial intelligent platform which the customer doesn't want. However, best it be, still the customer doesn't want it, right? So it's not going to have a huge impact. So even if it's going to be a simple impact, let's say, uh, I think recently we were able to see that in Rolls Royce kind of cars, it has a night vision view, which is able to clearly understand the difference between roads and traffic signals, and also human beings and animals. So what it says that in the next 100 meters or 200 meters, I can see someone standing, and there is a change in the technology. They don't just use normal technology. I think they use infrared rays and other technology based approaches to understand that such an object is existing. And coming to the traffic signals, that's the best Rolls Royce could come up with when we talk about especially night driving. So they have an enhanced feature called night vision, where you can see in your touchscreen that such a feature is available. And I just want to give you a caution note. So this is more of putting the customers forefront and having them surrounded with all these artificial intelligence tools to come up with the best approaches and best solving mechanisms. Now this particular artificial intelligent based approach is more of using voice recognition, uh, speech recognition, and coming out with wonderful algorithms to trigger a caution note, and also understand the technician questions and answer them. So this is more of an implementation oriented case study. There are This is going to be a highly complex one compared to the earlier one. The earlier one, again, image recognition is still complex, but the shortcut to do the earlier use cases, you can still go ahead and create a platform without image recognition. This one is more of a complex feature where we use voice recognition, and this is not something which can be avoided. So basically, what we are trying to say is, try to do things which are intelligent enough and which customer really wants. Thereby, you should show a lot of implementation based advantages, rather than being highly costly or difficult enough to implement. Because when it comes to the business, at the end of the day, it's more on understanding customers wants, rather than whatever R&D we want to do. So just give a thought before, whenever you want to build a platform, and then you can build it by changing certain things, understanding certain things, and then coming up with the best set of solutions. No, I think this is the last part I wanted to cover, and after that, it will be put open to questions and discussions. Now, out of what I have seen in the career track, I kind of have divided into three different flavors. One is going to be functional, the other one is going to be technical. So these are going to be end to end. And now there is something which is involving both technology and functional role. let's say, when I talk about functional, it's going to be your BD guy, your sales lead, and it's going to be a product manager, and it's highly towards consulting, and product development, and also, bringing in more, POCs or projects. So these kind of, roles are highly functional. When I talk about technical, I would say, all the research oriented roles, like say, artificial intelligent engineer or a ML researcher can be clubbed under, technical. I do not want to say data scientist as a highly technical role, because what we data scientists do is understand both the business problem and try to come up with a solution which actually solves the business problem. And there is a chance that, you have a project manager for any IoT platform or a IoT project or a IoT application. So when I say, these distinctions, it's always good to have a, clear understanding of the roles, do's and don'ts, or the expectations. Let's say when I talk about ML researcher, it's about bringing up new algorithms or changing the existing algorithms to come up with the extra feature, or make it highly efficient. So this is going to be highly research oriented, and people who work here are, highly geared towards coming up with new algorithms or new techniques which can improve the efficiency. When I talk about functional, it's going to be the other end. I want to understand what is the want in the industry, and what these functional guys does do is, talk with techno functional people or talk with technical people, and make them understand that this is something which, is wanted more in the industry. Can you come up with a good algorithm, or can you come up with a good mechanism whereby I can, solve these problems? So this is more of, they work together. There's no way, only one particular chunk of people come and solve the problem, and it just happens after that. That is a very risky factor, because once your algorithm is failed, there's no way, to get saved by, at any cost. So the algorithm is to be retrained, and hence you need a data scientist. The other way around, when I talk about project manager, it is more of, prioritizing things, understanding the complications of the algorithms, and also understanding the business requirements of the clients or customers. Let's say, I want an algorithm which, tells me how to improve my sales. Now, the question of how to improve my sales is, you can divide it into multiple things. I need a lot of insights towards my sales, positive and negative, and I also need to predict my sales. So thereby, you should build an algorithm which will give you more towards, prediction as well as insights, your prescriptive analytics part. So hence, you can't come up with, any black box algorithm which doesn't give you, let's say, insights or any depth into how can I improve my sales, because these are things which people will really want to, have a real time approach, and I want to see how good the algorithm is. So this is more towards, implementation perspective, whereas your technical roles are going to be highly towards, using the existing algorithms, coming up with new algorithms. I have seen people, changing the way SVM works, your support vector machine, and trying to build new support vector, algorithms which can, come up with better efficiency. You can see a lot of white papers which are being published, and one such, outcome which is very, which is being used across a lot of industries is your, LSTMs. We all know how, this came up. Andrew Ng, the most, prominent personality and professor across artificial intelligence stream, was the, master brain behind these kind of, algorithms. Particularly LSTMs is something which, they had devised and come up with, understanding how can I use neural networks without forgetting the past, and hence, I can give the best output. So these are some, complicated things, but it's more towards research. Whereas your functional and techno functional, you don't try to, create something new. What you try to do is use the existing things, improve the way it is working, and hence, solve the business problem. You try to understand the client's requirements and focus on, how can this be solved in a better way. So these are, a lot of career path. Again, this is a very high level. So the reason I have color coded in red is to understand the distinction between functional and techno functional. Obviously technical is something which people will be very clear, but the distinction between functional and techno functional roles are very sensitive, and people need to understand the ins and outs, and hence you can choose your career path. I would say there are a lot of universities which offer both techno-functional programs or technical programs as well as functional programs. So it depends on your aspirations, and I would say try to talk with these set of people, data scientists. Try to talk with consulting people. You will get more insights towards how these are being used across industry. So this is the my take on career path. Again, there can be multiple flavors of this, but on a high level, these are the three distinctions, and the difference and similarities. There are obviously going to be a lot of similarities and differences. Similarities, you try to create uh, you try to solve the business problem in a different way. You don't use your conventional approach. Now the difference is something where multiple teams work. I don't want to have a researcher at this point of time. This is something will get decided upon the business problem. If the client's requirement is towards come up with a new algorithm, then yes, you would have to do it. So when I say come up with an algorithm which solves my business problem, it is more towards a data scientist or a team of data scientists would work together and hence solve the business problem. So this is my high level overview on the career path. This applies both to IoT analytics, artificial intelligence, because all these guys work together hand in hand, and there is very less chance of distinguishing between each other. So we have a lot of firms which offer functional roles. Let's say consulting, KPMG, and a lot of Accenture and other consulting companies do it. Technical roles, I could see a lot of startups coming up with highly technical roles where a lot of research is being implemented and being used.